Hi everyone, today we're going to go over graphing quadratics. There are three different forms of quadratics. There's vertex form, there is standard form, and there is intercept form. And today we're going to go over vertex form. Vertex form, we really love that form because you can find the vertex with just looking at the equation. Where standard form and intercept form, you have to do some kind of math. So we'll go over standard form and intercept form in the next few days. So today we're going to go over vertex form. So notice in vertex form that it has an A out here, and the A is, right, what vertically shrinks it or stretches it, so it's going to make it either skinnier or wider. And then if A is negative, it would open it down because it has a reflection, or if A is positive, the parabola would be opening up. And remember, things that are squared are called quadratics, right? So those are called quadratics when you have a function that's being squared. And quadratics always graph as a U, and we call those parabolas. And notice that parabolas have symmetry. So if you were to fold this line and where the vertex is and fold that parabola, you could see that one half of the parabola would end up landing on the other half of the parabola. So they have symmetry. Okay, so let's look at the vertex. So remember, the vertex is the shifting. So your H is going to shift it either left and right, and your K is going to shift it up or down. So our vertex is going to be HK. So look at number 1, 2, 3, 4, and pause the tape and see if you can identify the vertex before I start, and then let's come back and see how you did. Okay, so let's see how you did. Did you emphasize, so again, the fact that this is squared means we're going to have a parabola, a U-shaped parabola. It is going to be opening down because it has a reflection. And then doesn't this mean it's going to go left 3 and down 5? So therefore, isn't our H negative 3 and isn't our K negative 5? So we say, obviously, it went left 3, so the vertex is going to be negative 3 and then negative 5. Right? So it went left 3, down 5. So negative 3, negative 5 is our vertex. What about number 2? Number 2, notice that it has a vertical shrink by a factor of 1/2. So I know that the parabola would be wider than the parent graph. I know it's going to be opening up because it doesn't have a reflection, and it moved forward to the left. So if it's going to move forward to the left, then wouldn't my vertex be 4? And it did not move up or down, so it just moved forward to the left. So we say our H is 4 and our K is 0. So the vertex is 4, 0. Notice in number 3, it's going to be opening down, so the parabola is going to be opening down. It has a vertical stretch by a factor of 5, so it should be a really skinny parabola, very skinny. Notice it has not shifted to the left or right at all. There is no shifting left or right, it's just shifting up 1. So that means our H is 0 and our K is 1. So that would be 0, 1 for our vertex. And in number 4, did you notice that it didn't shift left or right or up or down? So isn't our vertex 0, 0? It's opening up because the A is positive, and it has a vertical stretch by a factor of 2, which means it's going to be skinnier than our parent graph. So how did you do? Okay, so let's go to graphing. Okay, so let's start out with the coordinate plane. When you make a coordinate plane, we want you guys to graph. Unless we say sketch, when we ask you to graph, we want it to be done on graph paper. So you must use graph paper, not a piece of paper where you try to make your own graph. And then some kids will, they'll put extra tick marks in between the tick marks. So they'll go over top and don't do that. You're kind of losing the whole point of having a piece of graph paper. So I'll see kids do this and it's like, what are you doing? That's why you have graph paper. That's why we wanted you to do it on graph paper. So please don't do that. You do not need to darken in the marks. So some kids will darken it in and they'll, darken these in and waste time darkening those in. you don't need to do that. The whole point is you're using graph paper, so there's no reason to do that. So really all you need to decide is, are you going to go by ones like 1, 2, 3, or twos, 2, 4, 6, 8, or 3, 6, 9, 12? Typically go by ones and occasionally by twos, depending on your t-table and how big the y values are on your t-table. Otherwise, just go by ones. So you want to do your t-table first. So I'm going to go by ones, and if you're going by ones, you don't really have to mark your axis. But if you're going by twos, you definitely have to tell the reader that you're going by twos. So I'm going to say that this is 2, and this is 4, and this is 6. Now be careful, because some kids will put 2 inside the box, 4 inside the box. It's not inside the box. And this line obviously is 1, this line is 3. Notice I'm not labeling every single line because it's just busy and hard on the eyes, and plus it just takes more time. So I'm just labeling enough to help me when I go to graph, and just labeling enough to help me go along with the graph. So notice I'm going over top of the lines. Okay, so now we're going to begin. So is the parabola, remember it's a quadratic, so you need to recognize when you have a quadratic and say, oh, okay, that's going to be a U shape, that's going to be a parabola. You should know that because it has a reflection, we know the parabola is going to be opening down, and we know that it is going to have a vertical stretch of a factor of 2, so we know that our parabola should be, skinnier than a normal parent graph. The first thing you want to do is your vertex. So you must have your vertex in your t-table. So you must have the vertex, and I would put it as the first thing in your t-table. So the vertex is what is your h and your k. So in this problem, what is your h and what is your k? So doesn't that mean we went 1 to the left? So wouldn't our h be -1, and didn't we go 6 up? So wouldn't our k be 6? So obviously it went left 1 and up 6. So that is our vertex. And then let's plot -1, 6. So -1, 6 is there, and we know it's opening down, so we know it's going to go something like this, but we want to have a more accurate graph, so we can't just like draw a sketch. Once we have 1 point, we now need to collect and get a few more points so we can get a more accurate graph. We want you to put the axis of symmetry. We're going to use a dashed line for the axis of symmetry. That's where the parabola would be folded. So let's write axis of symmetry. We get tired of writing all of those words. Right, axis of symmetry. So for short, we're just going to write AOS. So for short, we're just going to write AOS to save some time for axis of symmetry. And what is the equation for the axis of symmetry? Since it's a vertical line, it's going to be x equals -1. So we also want you to write the equation for the axis of symmetry when you're graphing. Okay, so now what we're going to do, now that we have the vertex, we're going to pick 2 to 3 points either to the left-hand side of the axis of symmetry or the vertex, or pick 2 or 3 points on the right-hand side. It doesn't matter whether you pick points to the left or to the right, but you want it to be either to the left of the vertex, which is also the axis of symmetry, or to the right of the vertex / axis of symmetry. So I guess I'll pick points to the right because zeros to the right. So maybe I'll pick 0, 1, and 2 to plug and chug into my table because I like to work with 0. It's usually easy to work with. So that's what I'm deciding to do. It doesn't matter. So I am deciding to pick 3 points to the right of the vertex. I picked 0, 1, and 2. And I'm going to plug those into my t-table. And I'm going to see what kinds of numbers I get out, and then we'll plot them. So here we go. When you're plugging and chugging, I want to see your plug and chug work. So on your paper, I want to see that plugging and chugging work. So all we're going to do is plug in each of these numbers that I picked, and we're going to see what we get. So here we go. So it says to get the y value, we just do -2, and then x gets replaced with 0. And we're just going back up to the function, right? We're going up to the function rule. And I just substituted 0 for where the x was in the original equation. And then remember, we're not foiling like some of you are foiling in your homework. Just do order of operations. So order of operations says we do what's inside the parentheses first, which would be 1. Then we do exponents. So that would be 1 times 1. Careful, it's not 1 times 2. And then we multiply, and then we add. So when I plug 0 in, I got 4 out. So when I plug 0 in, I got 4 out. Input, output. Okay, so now let's plug in the next one. Why don't you pause the tape, and why don't you do the next 2 and see what you get? Okay, so here's the next one. So when I plug in, this time I'm going to plug in 1. Whoops, not going to plug in. I'm going to plug in 1 this time. And notice how I forgot the -2 in front. So I'm not copy. Got to go all the way back up to the original problem and make sure I copy everything in the original problem. And this time I'm just replacing 1 this time where the x was. Right? Because we're using the original function, which was -2 x plus 1 squared plus 6. And order of operations says you do what's inside the parentheses first. Then you do the exponents to, then you multiply, then you add. And then we're going to plug in 2. Do what's inside the parentheses first. Then exponents, 3 squared is 3 times 3, which is 9. Be careful. Watch your signs. And then we're just going to plot those points. So let's see what happens when we plot those points. So I want to see the plug and chug work on your paper. So let's plot 0, 4. So when I plot 0, 4, that lands right there. And then if you fold, since parabolas have symmetry, when you fold it, so look at how far, isn't this point 1 unit away from the axis of symmetry? So when I fold it, wouldn't it land 1 unit on the other side as well? Right? Do you see, start to see the parabola? And then 1, 2 would be plotted right there. Notice that is 2 units away from the axis of symmetry. So if I folded that paper, wouldn't it land 2 units on the other side, right? Because it has symmetry. And then we have 2, -12, and then 2, -12 is kind of off. So let's see, -10. That would be way down here. Sometimes if your third point is way off your paper, it's okay not to plot it, even though it's in your table. And notice that one's 3 units away from the axis of symmetry. Right? That one's 3 units away from the axis of symmetry, so it would be 3 units away on the other side as well. So 2, -12, I think it's right there. And so 3 units, so 1, 2, that would be right there. And then when you're drawing your parabola, make sure that you have a nice parabola. It should be a rounded edge. And if I had a regular piece of paper, I would turn my paper so I could get a nice parabola. Don't forget to put arrows on your parabola. So let's look at some parabolas that are not appropriate. So some students will give me a parabola that has a nice curve here, but then it goes straight up. Parabolas do not go straight up like this. Parabolas don't have a V, right? It's almost like you have a little V there. That's that's bad. That's bad. Some kids do what I call the tulip, and they have it go like that. Nope, it's not right. It should be a nice U-shaped with a nice curve at the bottom, and it should have arrows, and it should never go straight up. So if I see those types of things happening, I'm going to dock you points for that. So you're supposed to know what a parabola looks like. So make sure that you use a good pencil so that you can make a nice curve. Again, mine would be a little bit better if I had a piece of paper where I could actually turn it. Let's look at another problem. So one more problem. So, is my parabola opening up or down? Good. Did you say that it was opening up? And just by looking at it, I know that it's going to have, it's going to be kind of a fatter parabola because it's got a vertical shrink by a factor of 1/2. It has no reflection, so it's going to be opening up. And what is my vertex? So your vertex always needs to be as the first thing in your t-table. And don't forget to put V for vertex or write the word vertex. So let the reader know that that is your vertex. So notice that it did not shift to the left or to the right, but it went down 3. So it has a vertex of 0, 3, because it didn't, all it did was go down 3. So that means our H is 0 because it didn't shift left or right, and our K is -3 because it went down 3. Let me make that -3 a little bit better. So 0, -3 is right there. And then we're going to build our axis of symmetry. Our axis of symmetry is where it's the fold line, so we can get that symmetry on the other side. Let's point to that and write AOS, and then let's write the equation for the axis of symmetry. And the equation always has to be x equals because it's a vertical line, so that would be x equals 0. And then we're going to plug and chug by picking 3 points either to the left of the vertex / axis of symmetry or to the right of the vertex, which is also the axis of symmetry. So it doesn't matter. You can pick to the left or to the right, but don't pick some of both. I guess I'll choose and pick some numbers to the right because they're positive, and I like to work with positive numbers when I can. Less option of getting sign errors, so I'm being a little bit smart about my choices. So I guess I'll pick 1, 2, and 3. See what happens. I can always pick more. So I can pick as many points as I want. The more points I pick, the more accurate my parabola is going to be, right? So the more points you plot, the more accurate your parabola is going to be. So let's do our plug and chug work. Make sure you're showing your work on your graph paper. Also make sure your work is near your graph. So I don't want your work on a separate sheet of paper because I want to look at your work and your graph all together on one thing. So I plug in 1/2 times x squared minus 3, and I decided to use 1. So when I plug in 1 where the x used to be, order of operations says you do exponents first. 1/2 times 1 is just 1/2. I've got definitely negative because I have more negatives than positives. I took away a half, so wouldn't that be 2 and 1/2? So that's -2.5 or -2.5, either way you want to write it. And then I'm going to plug in 2 and exponents first. So 2 squared is 4. Half of 4, right? We should be able to multiply by 1/2 very easily. Half of 4 is 2. And then 2 minus 3, remember, is -1. If you find when you are graphing your parabola and things aren't kind of lining up to have that shape, it's probably because you made either a plugging, chugging error, a multiplication, integer error. Obviously something's wrong. And if it looks a little weird, look for your vertex, because most of the time when it looks a little funky or just kind of like looks a little weird, many times it's you started off with the vertex incorrectly. And then the last one was 3, so 1/2 times 3 squared. And 3 squared is 9, right? Got to do exponents first. 1/2 of 9 is 4.5, right? $9 divided by 2. And 4.5 minus 3, or 4.5 minus 3, decimals or fractions are fine, is 1.5. Okay, so let's plot those points. So if we plot 1, -2.5 is going to land right there. And remember, it's going to have the same distance on the other side. And then 2, -1 is right there. That has 2 units from the axis of symmetry. So the other point on the other side should also be the same distance. And then if we plot 3, 1.5 is going to be about right there. And that has 3 units from the axis of symmetry. So this should have 3 units. And if I wanted to, I could go ahead and say, you know what, I'm going to go ahead and plug in 4, see what happens at 4. So that's 1/2 of 16, which is 8 minus 3, which is 5. And 4, 5 is going to be right there, and that is 4 units from the other side, from the axis of symmetry. And now I've got my parabola. And again, make sure you have a nice soft curve here. make sure you have, go past it and put arrows. See, pretty good parabola. And then let's just go over a little bit of vocabulary. So does everybody know that when it hits the x-axis, those are called x-intercepts, right? So that's important to know. Where it hits the y-axis is known as the y-intercept. So this is the y-intercept. So isn't the y-intercept 0, -3? Isn't the x-intercept here look like it's about maybe 2.25-ish, comma 0? And then this one looks like it's, or maybe it's 2.5-ish, whatever, close enough. And this one looks like it's maybe -2.5, comma 0. So this one's probably maybe 2.5-ish. And sometimes you have to estimate. I just wanted to make sure you guys know that about the x-intercepts, the y-intercepts as well. So that's how you graph. You find the vertex, right? Plug and chug, 3 more points that are either to the right or to the left. I chose 3 points that were to the right of the vertex. And then I plugged and chugged each of those points. And here's all the different ones that I plugged and chugged. And then I plotted the coordinates. And then I just mimicked those points onto the other side for the line of symmetry. That's it. Ciao, ciao.